So I want to talk idea about I have for a new type of flying aircraft that would reduce energy requirements and much more. So briefly, I want to talk about something called a cycle rotor craft, which some people have built experimentally. And what it does is, instead of having a traditional blades, like a helicopter that either just horizontal, is like pushes down the air and also has lifting bodies, or ones that are sideways with a traditional fan, like in an airplane, it has rotating 4 or more, or it could be 3, bunch of rotating blades that are all kind of like aircraft wings that kind of resemble a carousel wheel. And each of these rotating things can either work like a wing where they go through the air and cause lift as they go through the air by creating high and low pressure. High pressure is created because high pressure is kind of normal, but low pressure is created because air over the top of the wing should travel the same distance to reach the bottom of the wing, but over a curved surface it has to travel longer than a flat surface of the bottom of the wing. This is also sped up by then to travel this fast, it kind of makes, when the air travels faster, it becomes lower pressure. And the reason for this, you can kind of understand, is that the molecules become more spaced out if they accelerate, sort of. Now, on the bottom of this rotating carousel, towards the air, you kind of have it working like a regular wing. But at the top, you tilt the wing so it's more up and down, vertical, and then it pushes the air back, producing thrust, and so on and so on. But this also, the suction of air over top actually makes it even more low pressure, increasing lift even more. So this whole cycle rotor idea could in theory produce a lot of lift for very, very little energy. There's numerous problems though with this one. I think they're all solvable, but some of these problems include that it is that you have to build a new thing that's a lot stronger than most just the airplane wings, and it's mechanically a lot more complex. So not only stronger, but you have to make it mechanically complex because this whole wing is rotating and moving in many different ways. However, we've built really complex wind turbines, helicopter blades, and other blades of flying things with different rotating parts that can tilt and stuff while spinning at thousands of RPM and strong. So I think it's doable. It just will take a lot of engineering and a major investment. There are also a lot of other ones, because besides what I talk about producing lift and actually thrust in actually a lot more controllable manner than traditional one, the lift is more evenly distributed along the whole entire wing. This makes for it even more efficient, because when you have like an airplane or something, this airs move faster on part of the one near the ensign. This takes away turbulence that sucks in air in all different directions or pushes air, that slows down the actual aircraft, and it also decreases lift because the air is not flowing evenly throughout the wing, and some parts of it is lifting more than other ones, and air is just chaos. But here you have even lift across the whole wing. This also means that you can actually decrease drag, even though it looks more drag, because your whole wing is not contributing to drag, it's contributing to thrust more. And so actually this is more aerodynamic, even though it doesn't look it. So the mechanics. It also can be quieter potentially. So, and another thing is spinning blades are not as easy, designed to be as efficient as this thing is, because spinning blades, the tip of the blades are spinning at a very different speed than the center of the blade. This causes air vortices and stuff to occur, which sucks up energy. But also means you're not using the space most efficiently, because the outer one has a lot more blank area where it might not be moving air, when the inner one might not have the same amount of area. So it might be too compressed in the inner side and have overkill. So, what is my alternative design? Well, my alternative design, I'm going to show a couple ugly sketches of it. But imagine instead you have like your normal wing with which kind of looks like this. Flat and curved upper surface. Air flows like this, over it, faster here and faster here. But what if we split this wing into two sections, so we cut out a section near the top, and we make that like a fishtail that flaps up and down. When it's up and it's nearly, and the top part is more flat, air is sucked into a gap in the middle between that upper and lower section. When it gets down, air is pushed out. Then but the air on the top, over top, because it's down now, it's tilted down, gets sucked in. That sucked in air does a couple of things. Also, because it's getting sucked in, also moves across in the forward direction. Now when you tilt it back up, it pushes some air, actually forward too, up like this. Kind of like it gets sucked in and boom, pushes up with vibrations. Like a ball that first gets accelerates to the floor at an angle, then bounces and goes back up. If the floor moves up, it hits it up with more speed. And when it gets more speed, more air is sucked into the middle. So this becomes a more efficient way of forcing air. And actually, this fishtail mechanism of moving air, which I'll show you a fish locomotion here, is more efficient than fans for moving air because there's less vortices and it's more even. Partly less vortices because it's more even. Another one, this picture kind of shows you how it works in fish, not the best, but you can see over top the fishtail that is the side that's away, not curling towards the body, but more away from the body. Water is being sucked. Other side, water is being deflected away from the body as it comes closer to the body. This is the part when this is the direction it's moving, that direction. And then if you turn it the opposite direction, now that water that was being forced away gets sucked and pulled back in and towards the tail and back and forth. And the mechanism that slowly makes oscillations that moves it forward. So now we have this fishtail thing vibrating, pushing air forward. What are some benefits of this? Well, we got rid of the fancy, we got like the cyclomotor property of making continuous air currents and sucking air and forcing it along the whole top evenly to make it more efficient. And it's much more efficient because of stuff. But we also got rid of some of the mechanical complexity with a cyclomotor. And we also can make it, because it's not as many moving parts and stuff and as complex or big, we can make these wings smaller and better and probably structurally stronger. Also because we don't have to move it as fast. And with the shapes designed. And also not the whole thing moving. So, what are some advantages of this one? Well, what are some other things we can do about this? And I'm going to just make this a nicer format in one section. Well, first of all, this whole fan wing idea, we've gone over the advantages there. But we can also make this even better design by tilting the wing in various ways. If we tilt the wing, we can actually make the wing have more or less thrust during the whole direction, and we control the thrust very well. So we could tilt the wing so it's almost vertical, so there's almost all the thrust goes into moving the wing up with zero forward direction thrust, and it's actually more efficient at producing thrust than a traditional fan or blade. So this is a very efficient way of producing thrust upwards. You can't do that with a traditional wing, and it's even better than a cycle rotor. Another thing we could potentially do with this is have it have a box fuselage. And a box fuselage is something that box fuselage is kind of a totally, sorry. We could also make these wings flexible. And I'll get back to box fuselage, I'm sorry. The flexible part of these wings could make it even more like a fishtail, which is flexible, and even help redirect the flow of air even better, increasing efficiency. And also, maybe we can use it to compensate for different air turbulences. Instead of having just 2 sections that vibrate, we could even make a more efficient version with more sections, and that could give you even more controllable thrust vectoring. Another thing that could be done is you could use this to have heaters on the wings. And that can give you help prevent frost and stuff building up in the wings and more, but it can actually increase the speed of the wings. Things by if it heats up between the 2 different things that come together and apart, that can act kind of like a jet engine or something, and can push the air out faster, making it fly faster. Or you can use the heaters to lift air like a hot air balloon below it and make it fly at lower speeds. This is not as efficient as the other methods, but it lets you put out more power quickly. Another thing is having 2 wings. Well, of course 2 wings, but 2 wings on one side, either one in front of the other one, or one on top of the other one. There's some advantages and disadvantages of both. Having it behind each other ones, if both of them producing thrust, will mean that you can make both of them, and if you balance it out right, means you can make both the wings smaller overall, instead of having one huge wing and one small wing. And it would give you more control by making it, you'll be able to lift or control the lift on each of these individual 4 wings, tilt and craft in a variety of ways. Or you can make it have very different tight turns by changing the thrust. Or you can compensate more for turbulence. But it can also swing down the wings, increasing aerodynamic efficiency even more, because you have 2 equal-sized wings instead of one wing that's like 10 times bigger than the other wing. If you put them on top of each other, we can use that to take care, suck some of the, use some of the air from both of them that's moving forward, and you can pull some of the air more forward, helping it. With kind of like having smaller fans are more efficient than bigger fans to some extent. Well, bigger fans are more efficient for the same area of having 2 smaller fans. You can suck up more air because less turbulence. So you can have that effect. But I will get to another effect of having it stacked that might be good. But what even may be better is having a future craft with even more wings, like 3 or 4 wings outside, because then you can make them smaller and smaller. But as soon as they get smaller and smaller, they can will have less friction, and you can do more maneuverability. But the electronics and stuff to control becomes harder. And what I forgot to say that's really important to mention, it's just all about making electric crafts doable, because electric engines and stuff are more efficient and much lighter weight, but you just need, it's unlike the gas stuff where you have the problem with batteries, and the problem with batteries flying is that flying is a lot more about weight, and batteries can hold more electricity weight in the beginning, but you never lose the weight. Well, fuel, you burn off and it goes out, and your craft becomes lighter. Another idea you could have to make this whole thing a little more fun is having the wings, because remember, the wings do not significantly contribute to friction as much as in older designs. And also the smaller wings, I forgot, the better turn radius and a bit more efficient this whole craft is in turning in particular. Is if you have it forward like a V-shaped, it might become more efficient, because you have less of the end effect where air escapes at the end of the thing and actually sucks away energy. At tips of the wings, air can flow away and suck out energy or move out because it creates turbulence. But when you have wings forward slanted, air moves more towards the middle, and that can compensate for that. Now, in aircrafts that do not use as much distributed propulsion, it's not the biggest loss of efficiency, and it also leads to less stability, so we usually don't do it. But with this, it's already becoming more stable with all the different distributed air cons, so it should be more doable. Another idea we can put down here is that we can use the whole wing as a cooling device for the engine much more efficiently, because the whole wing is really moving air more efficiently and distributed. So a lot more area for heat to be sucked away, which may be important in cooling battery packs, for example, more efficiently. So less of the energy is lost there, and the batteries can last longer and work better. Also with this idea is that you can use it to get feedback from the motors more efficiently. With electric motors, you can get feedback from the motors more efficiently and quicker. And you can use that to adjust the motors for turbulence and other things with automatic controls they can't have in a normal aircraft to lower the whole vibrations. In the wings, you can also pump in coolant more efficiently for heating or cooling down the whole craft, which we already do. And that's different than the solid method of heat distribution I was talking about before. We could also start adding smart controls, so we could change the flexibility of the wings, maybe. Because some materials can change the flexibility under electric ones, or you can pump in fluid or something, and that can lead it to be more or less stiff, which can make it more or less like a fishtail, but would maybe work you want it less stiff when you're working at lower speeds, but at higher speeds you want more stiff, or something like that. And that could potentially make it more flexible, or you could change the stiffness during turn or something when you're changing it between different configurations. You could also get feedback about the flexibility of everything or how much it's flexing based on better electronic controls incorporated, or you could have a camera or something to do all this stuff. So you got all that ideas. And then you have ideas where you have you could have it also have different flexibilities to help with wind or something, to distribute the wind more evenly across it in case wind is blowing it in turbulence, or that it sweeps back when the wind comes. You could incorporate vibrational feedback to figure out weather conditions or turbulence, or you can use vibrations maybe with like acoustic fan to actually pump in the air even faster and have vibrations at different levels. You have the big vibrations and the little vibrations, and there's a dynamic feedback for pumping liquids that is an active area of research. So I should get rid of those things. But another idea I have is to make the bottom of the wing more flexible in some ways, so it can handle better turbulence. Because in high air pressure zones, it might flex a little upwards and take in and making a lower pressure temporarily, or flex back in to low pressure one, kind of like a suspension. We could also make the whole thing a little more flexible, like a suspension, to go rid of it. Now, if you put the wing overhead, now instead of having the wing center like in most crafts, if you have the wing overhead, so on top, like you see some like cargo planes, you can actually make the whole thing stronger because it is lifting along the whole wing. Now, also lifting along the whole wing actually introduces less stress along the wing, because how would I say it? It's not one point that's feeling most of the lift, but having it more evenly distributed. But now having it at top of it, which is harder with the old design, you have even less stress on the craft because it's not pushing evenly just on the top, not pushing on the bottom differently than what, and stretching out the bottom and collapsing the top. Also, if you have more wings and more even along the whole craft, you can also reduce the mechanical stress. This is very different than cycle rotor, which will increase the mechanical stress. And now if you have wings over and under, you have the under vent is also mechanical stress. So now if you have wings over and under, you can reduce the mechanical stress even more. So And another thing you could do is even flip the whole wing backwards, or use the whole wing as a giant air brake, where you just lift the top of the wing that can move forward way beyond what you can do when you, and just increase the air resistance to slow down the thing, which is used by some fighter jets at sometimes when they're slowing down, or the space shuttle. Or you can even produce a little bit of backwards thrust, not very efficiently. So, some more things to cover quickly. Some of them are not as much directly related. You can also design this more easily with a box fuselage now in the future, because you're in a box fuselage, instead of being a round circle, if you cut a section for it, it looks more like a box, around the box. Now, a box fuselage has a couple advantages, and this is for all planes in the future. I'm sorry, box fuselage. And one is, if you can make it out of stronger material, it has more area inside compared to surface area than a round one. So it's actually, if it's just traveling, it can be, without, if you don't include turns, it's more stable and more aerodynamic, so there's less surface area. Now, if you have wings at the top or the bottom, most of the parts of the wings is more along this long beam, and along this long beam, and then a little bit along this one, and this shape becomes actually stronger than a circle. When a circle, it kind of reduces strength, having it at top and bottom. Another idea in the future to make electric ones, and not this design more practical, but electric ones more practical, is to have structural batteries. And that means the batteries are what kind of give the strength to the whole structure, so they're not dead weight. I mean, they're not. And then if you have the batteries are going to be overkill oftentimes with the strength of the structure, which will allow to easily make a box structure. Another idea I had, kind of along the lines, is to have removable wheels. And the idea about the removable wheels kind of is that if you don't land on if you can make this whole thing land on water, that's more efficient, because then you don't have to have wheels and all those mechanics, and it'll save weight. We could also work on making this whole thing much more airtight. So that means you have less energy loss in pumping in new air into aircrafts, and air would actually be better in the aircraft because this stale air comes from the outside. And you can do that by making the walls thicker and better insulated with all the batteries and stuff used. We can look at in-flight refueling ideas. So some of these in-flight refueling ideas are that we could have either another craft that flies, that is this efficient craft that I've designed, but a very slow version, and slow the other more efficient you can make them, that just has a long cable that sends in a lot of electricity fast. The problem is recharging is not as fast as it is with gas. You can still make it faster. However, you could have it that the cable reaches quite a bit, and the craft is also flying with the craft, so it doesn't always continuous. And maybe the craft also provides some of the energy to lift out the craft, so the other craft has to use less energy, so it's pulling it along too. The problem is that you still have to fly that craft up and down, so you still lose energy that way. Another idea for in-flight refueling could be to have this whole thing refuel using how would I say it, lasers and stuff to transport energy, but then there's usually significant power losses, like 10 to 30%, and you have to aim that laser and stuff right, and then there's questions of the dangers of that high-powered laser or beam of radio waves, which could really disrupt electronics. So it's not the perfect solution by far. Or what you could do, and I think for in-flight refueling that might make this whole thing more practical, is have the batteries actually be removable and then you replace it with a new battery system. And but making this whole thing again more efficient, you need less refueling. So you could also do this design with more motors, and the more motors you have in this design, the more efficient you could have this whole thing be, with having different things vibrate in different ways and more mechanically complex ways. You could also change the gapping between the wings for different air conditions, such as low pressure. You might want to increase the gap a little more, so you have more dramatic. We could also figure out how to make this whole wing a lot more stronger with wing integrity designs using AI and sophisticated machine learning, but we don't have to as much as a cyclomotor, again, because the whole thing is moving, and it's actually less extreme than a separate engine. Also, we got rid of engine weight, with this whole thing, because we don't have to carry the engine anymore, so the wing is the engine. So that's a lot of weight we got rid of with the fans and everything. I've already mentioned we can have acoustic monitors during the whole system, so these monitors would monitor the whole aircraft parameters with the acoustic feedback. So it would see if, for example, if something was broken or something, or the wing integrity was compromised, you could send sound waves or listen passively for sound waves to tell you how good the wing is with working, and is it close to breaking or damaged. And it could also give you feedback on air turbulence conditions, so it can change that. You also have camera monitoring for this whole thing. And with more sophisticated electronic controls, you can also land the craft using more landings based on gliding and stuff, or when you're waiting to be landed, to use less energy. So another one is you can, with better weather predictions in the future, we can use the weather to actually help propel the craft forward much more, and reduce fuel usage. We could also have it that, well, if it's a small drone or something, I don't think for a big plane, because you have a cable running in some locations, and it uses the cable powered and recharge over a longer distance, kind of like what we have in trams and stuff, but for drones. Another significant actually loss of energy for very high ones, for very good planes and stuff, is actually the windows and stuff like that, and they are a significant problem because they are either indented or they're outdented and can cause turbulence, but also structurally weaken the craft. Making stronger glass that you could melt into place and fuse it, or plastic, especially wood, which could be compatible more with future of using carbon nanomaterial composites, or carbon fiber composites. You can just melt a plastic into it and make a very seamless thing that loses a lot less strength. Another thing that may be in the future with this whole thing is methane or hydrogen powered crafts. Now, this is not the most clean fuel, and batteries are better for land or ocean, but methane or hydrogen might be better for just planes. And we can, if we make hydrogen or methane, if we make hydrogen from we can make hydrogen from solar power or wind power or electric power. Specifically, the step process is one of the most efficient ways, where we use solar energy or other energy to superheat the water, put it for a molten electrolysis bath, and electrolyze it. Molten electrolysis is the idea of using molten electrolysis uses something that's normally solid at room temperature and melt it. Then this hydrogen could be used to make, hydrogen is very hard fuel to use. It's not not because it doesn't have so much energy, but it's really hard to store. And then we can use, it's also not safety concerns as much as people think it is. It's really just storing it at a reasonable amount. Then you can use that to make methane, and methane has a lot of energy for the same size. Or biomass fuel, making it more efficient. Because biomass fuel is not very efficient. Or biofuels, they don't have a lot of energy, or they take a lot of energy to make. But if you take something and pump hydrogen into it, you can make it into lighter chemicals that store more energy. So you can get rid of some of the stuff. This design also might be, this design for the whole thing I've been talking about, might be also a very useful idea for just designing space planes. And what I mean by space planes is that actually not this for the space plane. This is ridiculous to work in outer space with no air and everything. But it might be like something like the Virgin Galactic one or something like that. Spaceship One, where it can carry heavy payloads much more efficiently, and it doesn't have to do this fast. And those payloads then can drop off and fly to outer space. Or it might be a more efficient space plane for like stuff like trips to Mars, or on Mars or other planets that have a lot lower atmosphere. You need to focus more on lift. Now two other final ideas that I talk about, three other final ideas, is maybe we can also have water runways in the future instead to make stuff more efficient, and that instead of pavement, because then again, you can remove the wheels, and water can also slow down the craft more nicely with its brakes in the water than wheels can. And you don't have to worry about, also wheels have to take a lot of stress and easily break and stuff. When water, the stress will be more evenly distributed along the whole hull. You could also have this have a ground effect mode if it's not flying super fast. And that is that if it's flying near the ground, and this has to be on the ocean or something, the air getting compressed getting compressed between the plane and the ground, or whatever you want to call it, can give more lift. And if that, along with the waves and stuff, actually producing lift by pushing air up. So there's actually air currents also near the ground that push the whole thing up more with waves and stuff. Now this would only work more near water, and it would also only work more efficiently at slow speeds. Now the problem with this also traditionally, I think, would really negatively affect wildlife is how noisy this would be with the jet engine. But we got rid of the jet engines with a lot quieter engines. They're also a lot quieter because they don't have to force air as fast out, so that more evenly distributed would also make it, besides being more efficient, more quieter that way. So impact wildlife a lot less if we do it this method. And the last idea is to actually make, and that was a funny misspelling, that's supposed to be black, the wing actually black, which actually can increase efficiency for moving stuff, especially if it's slow, or having heat only go into one direction in the wing, in between the plates, so you can change the heat conduction pathway in the wing to trap more heat in between certain sections of the wing. And what that does is by differentially heating the wing, you can produce even more lift for free. Now, we also have other ways we could do it, like black is from like solar energy, and it works better for small things. So only for small drones will probably be efficient that will go slowly, or for very large things that are gliding. But heat conduction pathways were complicated, that it cools off fast in one direction might work. Then other parts of it is more well done. You could also potentially maybe even do this for acoustic conduction, use acoustic by just the operation of everything, propel it more forward. But how it becomes more and more complicated, but hey, what the heck, I should list it. Well, thank you very much for listening. I think this is ideas could also just make drone deliveries in the future more possible for goods that are just hard to transport. Well, thank you very much for listening. Please like and subscribe, it really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, really how I think I can do it. Also, if any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Again, thank you very much. Goodbye.